Okay. Welcome everyone. We are going to get started here in just a couple of minutes. We're just doing a quick audio check.
Hello.
Artem, a man of few words.
I think I know who's driving.
How about now? Joseph, do you have any audio from us? It's going to be delayed a couple moments. There, you got it?
It was like a minute behind.
Okay. So yeah, it's going to be a little delayed, but there's nothing. I can only do so much about YouTube's delay because YouTube.
Yeah.
Cool. Okay. Sweet. Okay, should we get started? Can people see the screen that we have up? Is that good? Do we need dim lights? Going once, going twice? I'm not hearing objections. Okay, well, it's 12:01. We will dive in and get started. Welcome, everybody. This is going to be Test It Right, Sleep Well at Night, a title that was only mildly inspired by our AI overlords. We're just going to jump through a couple housekeeping slides first, and then we will dive in. So, we are the Spokane.net user group. We also have potentially people from the DevOps meetup as well as the Python user group as well. Don't panic. I don't believe we have any .NET code to show today, so don't freak out about that. It just means this is going to be a little more theoretical, a little less practical. Welcome, everyone. In Teletech, we are always looking to hire more local developers. So for people online, people who are sitting here, you all work here, so we're not looking to hire you. For everyone else, if you're in the area and interested, we are always looking for people who are passionate about learning. We'd love to find people who like learning more new technologies, because oftentimes we'll throw you in the deep end and say it's time to learn something new. .NET user group, meetings to be announced. For those of you, you're already watching us on YouTube, so I'm trusting you already know where the link is to be able to find them. We've been doing a bunch of these lunch and learns streamed. Sometimes they're a little more informal type setups, but keep an eye out for more of those to come. And then the Spokane Python user group. The next one is going to be, let's see, today apparently, Joseph, is that correct? I did.
Yeah.
Cool. Yeah, so the Python project power-up is later today for all of the Python people. Joseph doesn't look too surprised, so I'm trusting that he has that well in hand.
No, I saw the June 5th. I was like, that's not right.
Yeah, June 5th, coffee and code. Don't panic. That's easy. And then we also have the DevOps user group as well. So oftentimes run by Phil, always looking for more speakers or anybody else willing to present. Fourth Tuesday of every month, very much a informal lunch and learn style. Come with questions, topics, etc. Okay, and then Intelitech, social medias, all the things. Again, I'm trusting most people have found the YouTube link already. If you'd like to follow us on Twitter and Facebook, There are the links there as well. Okay, and now we're going to put the camera back on now that I'm not going to be covering stuff up. There we go. Okay, so my name is Kevin Bost. I'm a Microsoft MVP, Senior Software Architect here at Intelitech. And my willing cohort, who I only mildly tricked into doing this with me, is Artem. He is actually one of the best people I could come up with to actually do this talk with. He is incredibly passionate about testing code and testing it well. He's one of the few people that we can get into very long discussions over what is the proper way to test something and how to do it. So thank you, Artem. His title is Senior Software Developer, I think, but I don't think that appropriately covers his skill set.
Senior ranter.
Senior what?
Ranter.
Senior ranter, we'll go with that. You may need to speak up. You're a little
Okay.
quiet spoken. Be loud, talk loud.
All right.
People, happy. It's a fun thing. Okay, and if the slide wants to advance, go. There we are.
So
TDD.
TDD. That is test-driven. You want to just advance that?
You tell me when you're ready.
That's
I'm just here to help
test-driven.
you.
All right. TDD is test-driven development. It's the idea of doing tests before you do code. Essentially, test code refactor is the loop. It doesn't really cover. It doesn't prescribe unit tests or any specific type of test. The idea is that you just build an automated thing to verify before you do the code. Essentially, that's the core tenet.
Yeah, and just to re-emphasize that a little bit, this is going to be the only part of the presentation where you see the words unit test.
Yeah.
After that, a lot of people get TDD and unit tests conflated and brought together. Turn that portion off. Forget that anyone ever said that to you for at least the next, 30 to 40 minutes, please. I keep losing focus.
Fun fact is, I consider that most people that use a compiled language are doing some form of TDD, in that the compiler enforces a first check. You say that, hey, I'm going to follow this syntax, and the compiler tells you whether or not you are before you run anything. And so that, in some ways, everybody's already doing a little bit of it. And so the idea is to expand it further. So the point, why bother? And it's a mental shift to change how you think about writing code. Like it helps you get good design. Like it produces more correct results because it requires you to define what correct is before you set out to do something.
Yeah.
At least for this iteration. It's not waterfall. It's so not everything has to be defined ahead of time, but for what your task ahead, that's the key point.
Yeah, and I want to call out that first point there, that TDD is a tool for designing your code, right? People often get hung up on that first letter. The T is for test, but the more important is the D, design. That is the intent. The tests are a byproduct of the design. They're not the end. They're not the goal in and of itself. Right? The goal is to design your software well, design your code well, and lay that out. Focusing entirely on the test is how you get people suckered into that unit test mentality of, okay, I have to write tests first, I have to do this, rather than going through, like Artem was saying, of getting your head in that right spot of what should this code be doing? How should this code be working? And then just kind of a brain teaser to let propagate in your head for a little bit is, in thinking of your projects and the code that you're writing, what is the source of truth? When you get a requirement for your app, is the source of truth your implementation of that requirement or your tests? Because there's a mental shift there. Oftentimes when people are doing this work, they'll write their implementation, and again, whether you write the test first or second is a little bit of a process thing, but at the end idea is to get you to think all the way through that. Could you delete your code and rebuild it from your tests? Do your tests accurately capture your requirements? So, noodle on that for a moment. Good?
Yeah. So, this is TDD. It's not always the correct thing, or not always possible. And like the biggest thing is it requires understanding what you want in some way. And if that's impossible, if at a higher level, like you cannot describe what you even want, then it's hard to code that into a test or any other sort of tool, because you can't automate that. It's too subjective, essentially. And part of that is, though, maybe it's still the right thing if you go down and break down those requirements, and really, in some ways, it forces you to think, maybe I'm thinking this is too big incorrectly because I am. But at some point, it can't happen.
Yeah, to give some examples of that, you can imagine if you have a requirement of this should look nice. How do you codify that? That doesn't really work well. That isn't something that can easily be captured in there. Now, if you get down really specific, maybe you're implementing a UI framework. I'll pick on material design because it's my favorite. When you get down to that point and you've got a very specific requirement of, okay, I want some helper text. It should be inside of my text box. It should be offset by this amount. Okay, now we're at something that we can actually codify. But there's oftentimes requirements that come out of the software that are not easily codified. Right? One of our projects, we were effectively building a video player. The idea of video should play. How do you codify that? What constitutes a playing video? Right? Just if you see the pictures change, does that consider a playing video? In our case, that's not always an accurate test to know what it is. So there's some requirements that are not easily captured in a test, per se. Yeah? Okay. Yeah. But for most of your stuff, testing is essential. Like, people get hung up on the exception cases and forget that the vast majority of times you can test your code. There's a common idea that people will get into this, well, we can test our back end, like C# code, but we can't test the front end UI. That needs to be like a UI test or similar. Okay, possibly. The question comes back to thinking about what are the requirements and can you actually codify those into a test? I'm gonna keep going.
Okay. So, talking about some of the benefits of why we do TDD, I think like that loop of writing a test, seeing it fail, seeing it pass, but then going and refactoring. Like, I've never done anything that can beat the speed of that. Essentially, it's running application, doing through all the steps. Like I've done a lot of manual testing, and it is vastly slower than testing using automated tests, essentially. And that said, I would say TDD is more productive for this reason alone, in that it doesn't let my mind wander because, hey, this thing is taking a while to load, or this thing, like, it still happens, but it pushes that down to be fast dopamine hits of feedback.
Yeah, and I'll put it another way too. Again, people get caught up with this idea of what type of test is it? Is it a unit test? Is it an integration test? Throw that out for the moment. Going through and thinking of it, I was building a client application that needed to hit a web API. We wrote a whole bunch of tests against that. But those tests actually hit a legit API. These were not, by the classical definition, I can't say the word unit test anymore. These were not fast tests. They are slow tests. See how I did that? Flawless transition. But the speed of launching those and doing that validation in the test runner was significantly faster than trying to do it in an app. Right? If you think of the test runner as another way of being able to get in and do that exploratory work.
Yeah, I would almost say though too that the other part of the tighter dev loop comes from the fact that you're not having to think, is this correct? every time you make a change. Like, is this actually making progress in a way that you have to before? Like, I'm saving on that mental load of, oh, hey, this is, let me evaluate this list, look through some method that returns a list. Like, is this correct? Does this have this thing? Like, I do that once ahead of time, and like, I'm not just doing that just for that basic. I'm writing it the first time, non-regression stuff. Just it saves on that mental load, which is lets me go faster in making the next change.
Also, too, if people have questions, feedback, please feel free. A bit of a discussion here, because this is one of those areas with TDD that we can only give you so much. Imagine looking at pictures of a vacation versus actually going somewhere. We can only give you the pictures. We can't actually take you on that journey. I got ahead, didn't I? Keep going, you're doing great.
So yeah, the other part of TDD is it changes. I mean, it requires a change, but it also forces a change of changing how you think about doing anything. And I think, like, I've written a lot of many years of non-TDD stuff, and the general way I go is I read something, I code something up, I see if it fits. And that's what that produces is, well, crappy code.
I wasn't going to say it to your face,
yeah,
but okay.
But essentially, this TDD forces you to think, to be able to write a test that makes you decide, what am I trying to do? Like, what am I trying to achieve? What are the basic inputs, and like and so that thinking about that ahead of time essentially is the core tenet, I think, of TDD.
And again, this goes back to that idea of thinking about the D for design, right? Of the answer to the question of what am I trying to achieve, that should be pointing you back to that design of your code and the design of the test.
So this is a fun part, because I've seen a lot of tests, I've fixed a lot of tests, and like the moment I see a test, I can tell whether or not it was written before or after. And that I can't quite describe it, but there's a certain fragility that comes with writing tests after that like doesn't appear with before, because you end up writing, when you capture them before, your tests end up being in a way more pure to what you're trying to accomplish, and therefore don't have some of the stuff, and therefore your design doesn't have as many dependencies or anything, because you couldn't think of them ahead of time, and so you push them off to somewhere else essentially. And that, whereas afterward it's like, I have this implementation, I'm going to write a test that makes this implementation pass, and therefore, and so when that implementation slightly changes, but the underlying what it's doing does not, you end up having a broken test that is in some way invalidly broken. Whereas it happens less when you do test driven.
Yeah, as a practical example, I was pairing with a colleague, and he'd written the method first, was going to go write some tests. Great, fine, we'll deal with that. First thing I told him to do, collapse the method. Don't let yourself see the contents of the method. This comes back into that idea of, if you were to have written the test first, you would typically be looking just at the method signature and then building out the implementation to match the test, right? And like Artem was saying, you can almost see that difference in change of the test when it was written after the fact, because oftentimes the test is very tightly coupled to the implementation, right? And you want to break the idea of trying to think through it ahead of time is to not have that coupling, right? You want your test to capture the requirement, not the implementation, because you should be able to swap that, and as long as the test for the requirement passes, it doesn't matter what the implementation is, right? Maybe you lack some tests and therefore something's broken, but that's a lack of coverage, not necessarily a flaw of the setup. Yeah. Does that make sense? I'm getting I see some nods. Everybody's quiet. It's It's okay to yell at us. If you're going to throw things, aim to this side, please.
Any questions on the?
Nope, I'm watching.
Okay. And this is again same as kind of number 2. Like thinking about what you want to achieve makes you write more intentional code, not seeing what sticks to the wall sort of thing. And that, I mean, that produces higher quality code. I mean, thinking of like an example of this where
I was going to say, I'll pull one out. So there, and again, this idea of being able to experience this, there's a mental hurdle people have to jump over to get to this point, because oftentimes people have seen testing done poorly or only done part way, and so there's a little bit of a bad taste in your mouth of, I hate this food. It's, well, of course you hate the food. You only had half the ingredients mixed into it. That does not produce a good result. There was a project I was working on, and we were having this lively debate about this internal property on a class. And, what was its purpose? Do we need it? Yada, yada, yada. And one of the seniors on the team made the comment, he's like, this is dead code, we can delete it. And I'm looking at it going, I see like half a dozen references. How is this dead code? Well, he has the code coverage turned on. He's like, this property isn't hit in any code path covered by our tests. And because there was a high degree of confidence that every requirement was captured by those tests, it's like, we can completely delete this. We will not lose any requirements by dropping this property out. Now, there's obviously going to be some fallout because there were clearly references to that. But the idea and that mental shift of, wait a minute, dead code is code without tests. Not dead code is code without references. That's a very different shift and requires you to have tests that you believe you've actually covered your requirements with. And again, if it's only done halfway, you can't have that full certainty, right? If only some of the team is actually covering their requirements with tests, you can no longer make those types of statements because, like, well, did Artem write it? Okay, we're fine. Did Kevin write it? Oh crap, we're screwed, right? Those types of things come out when it's only partially done.
Before you go on, I think with the more intentional, just to go back to that, like sometimes when I code, say especially without tests, like what ends up happening is I'm building something, it works, I leave behind some like thing, I forget about this piece of code that does this thing that doesn't even matter, but maybe even wrong, but it's that moving your I work on this thing, I forget about the other things. I work on this, I forget about the other things. And by thinking ahead of time about what you're trying to accomplish, you end up, you get a test, so you remember the things it's supposed to do and the things it's not supposed to do cause things to fail. And just thinking, just being more intentional, it forces you, like all of these things essentially, all 4 of these points is the TDD is a constraint, kind of like how a lot of art styles, they put an artificial constraint on your style just to make cooler, creative things. And in some ways, this also forces a constraint of, hey, to write my code, I need to have a test, which requires better design. It requires you to understand what you're doing ahead of time. It gives you faster dev loops. There's some benefits, but it's a constraint that requires you to, forces you to do better, essentially.
Yeah, so we'll hit our last point, and then we've got a question online to come back to. I'll cover this one because you talking about yourself is weird. So there is an idea about enjoying your work. And Artem made a comment earlier in the week or last week or whatever it was of, there's days where it's like, man, my job feels like a drag. This has not been a good week. Things are going poorly. Why has my week sucked? Oh, I haven't been writing tests, right? Having those guide rails oftentimes adds happiness, enjoyment, dare I say it, fun, of being able to actually know that you aren't breaking stuff. there's that bit of fear that always creeps into people's head, especially with legacy code bases. This happens a lot. Something wasn't tested, you're going in to try and fix it. It's like, can I change this? What else is this going to break, right? I'm pretty sure this thing's unused, but hypothetically, maybe there's some reflection and your world falls apart because you deleted the thing that was unused and now everything's broken, right? That is a real thing, and at least I'll speak for us too, it causes a small amount of anxiety when you don't have those helper guide rails to go along with it.
And I end up spending those grumpy weeks. Like, I end up spending time just trying to think about the implications, it's a much higher mental load, which with much less being done. And so I don't have those dopamine hits of, hey, I made progress here. I can see it. It's solidified because it's a test, and so I won't accidentally lose it.
Mm-hmm.
And so it makes the flow a lot better, and just it makes me happier.
So the question from online, can you give some high-level guidance on testing heavy I/O systems, extracting data from files, writing to a DB, SQL, publish results to a REST API, handle REST requests, specifically design by test approach? Is that a long one for you?
Yeah.
Go and take a run. So, so there's a lot coupled in there, and so I'm going to try to break it down into a couple smaller pieces, and then Michael, keep me honest to make sure I don't miss anything. So for the higher I/O setup, there is a bit of a trade-off back and forth. In an ideal situation, all tests just execute the entire system and we validate the whole thing. The problem is practically that doesn't work, right? If we could just run all our tests against prod, hit all real systems, all real data, do all of the things, automate all of the process, that would give us the highest degree of confidence that everything's working. But from a practical standpoint, we almost can never do that, right? Those tests that run the whole system are big, they're brittle, one small change breaks all the things and nothing works, right? So there's the higher overhead, there's the higher infrastructure, how do you set up item potency, all that stuff comes into play. This is one of the areas where I would push for a shift left approach where possible. But with the idea of TDD, you still have to come back to the idea of design and what are you actually doing. So going back to the example I picked on earlier where we were building a client library against an open API spec. Not difficult, but writing UI tests, or writing the thing formerly known as unit tests, was not really going to give us much confidence. The API wasn't well documented. We had a rough idea of what it was supposed to do, but the documentation conflicted with itself, and so we're like, we really don't actually know what this thing's going to do in all cases. So we wrote some actual tests to go and pound on it. But there was a trade-off between how many of those tests do you write, and especially if you're hitting an endpoint that maybe is creating data, right? How do you clean that up? The unfortunate part is there's no silver bullets, because in each of these situations, the answer is going to be very specific to your application, the infrastructure, what you're going with. Third parties get to be another huge pain in the neck because you probably don't control enough to do anything. I can imagine some of the stuff that we've done against like payment processing services, right? Most third parties worth their salt have some sort of sandbox environment that you can play in to go against. And so what I would say is don't get too hung up on the idea of what type of test are we writing. If we go back to the idea of what am I trying to achieve, back up that second point, in our case what we were trying to achieve is a high degree of certainty that our client library worked against the API that we were hitting on, right? That's what we were looking to do. We wrote tests to meet that. What else you got?
I think the other one of handling these like I/O, REST, things that have more overhead, is to use the proper abstractions. Like again, this forces you to design your system in a way that allows it to be tested. And that essentially pushes out those as farther out as you can. Those actual requirements where I need to hit real I/O, like, okay, then that's a test that hits real I/O, and that's what in that small section of code, that's what I'm doing, that's what I'm testing. It's slow. I don't run it every time I make a change. But other times where once I get it off the wire and I do something with it, that can be abstracted away. The wire can be abstracted away, and you can test the next step by itself.
I said I wasn't going to do it, but I'm going to do it anyway. So there is a library out there, system command line, that if people want to see what this happy vacation of TDD, the end result, can look like, you can go and take a look at that. The problem is if you're looking at the library from the outside, you're only looking at pictures, right? Once you actually get in and start working with a library that has this level of testing, there is a different level of enjoyment that comes from having something where you've got that level of testing. We did a whole bunch of performance work, and there was an outside developer that came in, wasn't real familiar with it, expert in performance, and started making changes. And his comment at the end is, it was so nice having that test suite. He could make as many performance changes as he wanted, and he knew that if all the tests passed at the end of the day, his change was fine, right? And we told him straight up, if the tests all pass, you're golden. If you somehow broke something and all of our tests passed, that's a flaw of our tests, not a flaw of what you wrote. We didn't capture some requirement that you ended up going through and breaking. The other thing that is worth considering is there's a pattern that's employed there, and it's not quite equivalent of, because it's doing so much command line stuff, .NET system.console is your way of writing stuff out. The problem is for test, system.console is a rat's nest and a nightmare to go through and deal with. It's a static class, all the usual things that you might see with kind of legacy code bases and coupling. That library, anything going against system.console, you have all that kind of ugly coupling built in. What we ended up building is a memory-backed version of system console, something that we could do. And then we wrote a set of tests that actually went against the real system.console and our memory-backed version of system.console to make sure they behave the same. And once those tests were passing, because those were arguably not unit tests, they were legitimately hitting standard I/O and going through and doing things. But once we had an implementation that we knew was a good replacement, we just used our memory-backed version on all the rest of the tests. So having, like Artem was saying, setting up your system so that you can do that level of testing, oftentimes for those kind of heavier systems, not just using a mocking library, because it's easy to go through and put your web API, your DB behind some sort of interface and just mock it away. The problem with mocks is that they don't give, the mock may or may not behave like the real thing. And without any level of assurance that your mock is behaving like the real thing, it's anybody's guess. That's where you end up running into that situation. Everybody who's done a lot of mocking in their tests, that seam where you're going against the mock, that's how bugs creep in, right? You can have perfect code coverage, but because you're using a mock and you've got no guarantee that that mock matches the real implementation, how do you know that your test is valid or that the code is valid?
Yeah, though I would push back on saying mocks are bad, because mocks, what they
not bad. They serve a different purpose.
Yeah, they serve a different purpose, but in some ways they produce maybe better design, also because they say that implementation does not matter, as it should in many cases. Like,
it's true.
Who I'm using, as long as they give me this input, I'm going to do this thing with it. How they get to that input is not relevant to the point of, like, this is test isolation kind of, which is somewhat required for TDD, but somewhat separate. But that's what I'd say about that.
Cool. Thank you, Michael. Okay, so let's jump on forward. So real quick, and if people online would like to drop in, I'm curious to hear people's answers. When we sent out the invite to this, I even posted on Twitter, and I asked several people around here the question, what stops you from writing tests early? Or first, but I won't necessarily put first on that. What stops you from writing tests early?
Bad habits.
Bad habits, that is definitely That one, I struggle to fix people problems with technical solutions, so that one's harder. Joseph.
When it's like a lot of effort to set up the test.
When the test setup requires a lot of effort, yeah. Okay. What causes it to be a lot of effort?
Probably a poor design of the system where you have to set up way too much stuff to actually be able to test the thing you want to test.
So poor design in the system that causes you have to do a whole bunch of extra setup and that kind of thing. Yeah. So I think without fail, just about every answer. The bad habits I don't know if I covered. That one I don't know if I was ready for.
It's a mental switch.
It is very much a mental switch. Yes. Yes. Yeah. So the answers that we got, kind of polling people very informally ahead of time, typically fell into just a handful of buckets, right? And the most obvious one that came from a lot of people is, how am I supposed to write a test? I don't know what the code's going to look like yet, right? You're telling me I should write a test first, but how do I write a test against something that's not there, right? And that does switch back into that mental idea of what do you want it to do?
Which seems as a negative, but that's exactly what TDD is trying to push you towards, is not knowing what the code will look like, but deciding what it should do.
Got it.
Focusing on that end result without knowing what the process to get there is.
Yeah, and Jack threw in online as well, if the code already exists, right? Very much the brownfield development case of, I've got this legacy library, I need to make a change, how am I supposed to write these tests for it? Yeah, and then writing tests early when when something is to change. And I think this one here, in a lot of cases, some of the comments about the brownfield, or even Joseph's comment about it's difficult to set up, is the code's not easily testable. Whether that's the thing you're trying to test is not easily testable, or even the idea that your system requires so much work to get me to this point where I can actually run this test, right? This becomes difficult. And oftentimes, if this is greenfield, this is a very solvable problem. This gets easy. And oftentimes in these talks, people will focus on, well, if you just design your code this way, it becomes easily testable. And they just hand wave and pretend like legacy code doesn't exist, and that's not a thing anybody deals with. It's like, actually, that's like most of what we deal with, is this legacy code base of coming in. Yes, it's nice when you can go in and build something from the ground up, right? But you come in and you go, oh, I know, I'll just add a dependency to this class. It's like, right, this project doesn't have a DI container. That isn't going to work, right? You run into those types of situations, so it's like, okay, hang on. How do I go through and actually practically do this? And this is definitely one of those areas where I want to give people silver bullets, and there won't be any. There are ways around it, and there are a great number of talks that I've seen where often the pattern goes, okay, you're going into a situation, you need to refactor something that's not working, right? It's not, how do we build that test on top of it? How do we actually go through and do it? And oftentimes the approach taken is try to write some tests first to at least capture what it's doing, right? If possible, because most of the time we're going in and fixing a bug, let's be honest, none of us write perfect code, except for Artem, he's perfect. The writing a test that actually captures that failure state is the ideal situation, assuming it's possible. Sometimes it is really ugly to go through and do. I was working in an area of code just the other day where I wanted to go do some testing, but the amount of setup and coupling that was in that class was enormous. But I was like, okay, let's back up. What am I actually caring about doing, right? In this case, it was, okay, I need to pop a dialog. I want to make sure the dialog has the right content. Okay, that's the problem. Let's figure out how I can refactor at least this little bit of the code such that I can verify that the right content is making it all the way through, right? Breaking it apart in those situations, and again, I wish I could give people silver bullets. There aren't any. But not having the test is a ball of mud rolling downhill.
Yeah, but also having tests becomes a ball rolling downhill as well, of diamonds. I don't know, something positive, but it's kind of a virus. Like you find a system, you make a change, whether it be a bug or a new feature, and it's, hey, what am I trying to preserve? What am I trying to build? And you capture as much of that as you can, given your how much time is available for this. But the idea is that every single time you do that, the next step is faster and faster and faster. So like, I'm not recommending you have a brownfield with no tests or terrible, fragile tests that were written afterward. You go in and refactor everything. Like, if you have that time, it's a great place to be. I'd love to do that, but that's never in the business's interest to do that. Like, and so we shouldn't be doing that either. However, slowly moving something towards a tested thing as you're making changes, I think that is in everybody's interest.
Yeah, and I've come into several projects where the testing was abysmal, and the idea was, okay, we don't have time. Nobody's going to allocate the number of dev hours needed to actually go and get this thing fully tested. But what we can do is say we aren't going to continue propagating the problem and actually start building things and refactoring as we're adding new features. We can make sure we can quarantine off the ball of mud, as it were.
Yeah. And some people may disagree, but if something takes twice as long in the beginning just to get it started, some feature, like I had this feature, but to be able to do it in testing, it's going to take twice as much. In my opinion, that's time well spent.
Yeah.
Like some people might disagree with that, but you have to pay that cost, and that cost just multiplies over and over and over again to where it easily equals, multiplies my own brain and ability to write code essentially and make sure it doesn't break everything. Like, there's two of me. If there's tests, there's two of me and two of everybody else, and on it goes. And so it's a high cost, especially in brownfield. That's where it's a lot more of a cost, but I think it's worth paying chunk by chunk and investing in that.
And on the note of paying the cost, oftentimes it's worth, when possible, documenting which bugs are tied to which features that they came out of. Because oftentimes there's this push to say, get the feature done quick, get it out the door, right? And the business easily looks at it and goes, okay, one option without test took me 50 dev hours. With test would have taken 100, right? But if I've got 75 hours worth of bugs that I then spent fixing, that 50-hour savings wasn't worth it. In fact, it cost me more because that cost of bugs increases as things move further down the line. You don't want to have that problem occurring. And oftentimes it's a matter of making sure that people have a way of have visibility into that as well, right? There is a question here, when do you throw out tests? There's a loaded question for you.
I would throw out a test when it is no longer capturing something I care about. That's if it's, hey, before we required all new customers to have an address, and then GDPR came around and said we probably shouldn't store that, and so I throw out that test because, hey, I no longer want to do this. This is no longer a valid thing to do. Or maybe a different scenario is like, hey, this thing has refactored. I've moved some responsibilities here, some responsibilities there. I removed this edge case just from that. Like, that's not an edge case. It's no longer possible, so I just removed that edge case. Like, that's stuff like that can happen as well.
Yeah, I feel like I throw away tests it's hard to say throw away because it's rare that I just straight up will go and delete the tests. Oftentimes, tests go away due to refactors or changes in the system, so it's not necessarily, I may delete test A, but I may write test B instead. So there's that shift in requirements. So building on what you said, if the requirements dropped, burn the test to the ground. But oftentimes as the refactor comes, the other time that and again, I don't think it really is completely throwaway tests. Sometimes I come across really garbage tests, right? A test with no assertions is generally very low value, right? I mean, a test that doesn't throw an exception is a passing test,
Yeah.
so no assertions can sometimes work, but it's rare, right? If you have an assertless test, you should at least have a comment telling me not to delete it because my instinct is burn it. Or if I go and I found tests where I look at the test and it's not actually testing anything, right? Somebody's been using mocks and they've effectively mocked away the thing they thought they were testing. The test is worthless. Burn it to the ground, right? If the test is not capturing capturing an existing requirement, either change it or burn it.
In a lot of those cases, yeah, burn it is so rare because it's usually changing. Like, especially if it's named decently, and it's like, oh, we want this to happen. This is not at all testing what you're saying you're supposed to be testing. Let me go in and capture what I think that means, and with assuming it's supposed to pass. In other words, but just.
Yeah, I like Mike Kern's comment on here on the test and refactoring side, using the phrase "How do you eat an elephant? One bite at a time." And so the idea of being able to slowly move towards a better set of tests. Should we get to point 3? Don't have the time. Yes. This is one of my favorite ones because oftentimes when I hear people say don't have the time, what's subtly implied under the hood is either I don't feel like I have enough skill to write this test in a time efficient manner, right? The code is too bad. I don't know what to do. I can't do this. Or, the business is expecting this. They don't want to allocate the time for this, right? Those kind of one of those two cases is usually what's being subtly implied under the hood, right? On the note of not having time because you don't think you have the skill to do it, that is awesome. I love that. Let's talk. This is a fixable problem. This is a technological problem. I can solve those. I'm good at those. Those are what we can go through and do. And there's a chance there may end up being additional training on a little more practical hands-on on doing this, because sometimes it's just a matter of showing somebody how to go through and structure tests. Right? I'm biased. I like mock, MOQ. I like my auto mocker. I like those types of setups. I love to build out extensions on them and factories and things to make sure that my tests are simple and concise and easy to write. I was working on a test the other day, and I pulled Kenny in and I said, okay, here's what I'm thinking. And I didn't show him any of my code. I showed him my test and said, what do you think of this, right? Who cares what the method is doing? Who cares how it's implemented? What do you think of this? And then we had a great discussion around, well, this seems a little off. That doesn't make sense. And it was entirely focused around what is the design of this thing. And so starting from that mentality of going through and showing, I didn't tell him I hadn't written the method, that it was completely stubbed out and didn't work. That was irrelevant. I didn't bother to run the test. I just showed him the setup of the test to get that idea of, here's what I'm thinking. Does this make sense to you, right? Because, heaven forbid, he might have to use my code.
It's that what I mentioned before, like it's more time up front, but it always pays off. And I think most of us work in that world of not just one-off. I built this, I ship it, I never look at it again. Like, that's not our world. And if that is your world, maybe this isn't the right place. Like, because in that case, then your code is not used if it's not breaking and being maintained.
Yeah, there's one more comment online about, and I think this goes back to the idea of getting rid of tests, of ignoring with a comment on why, of suppressing it. I view ignored tests the same way I view like obsolete methods. They aren't. They have a time and a place, but oftentimes an ignored test becomes a test that's never run and can probably be deleted. Most of us should be using source control of some kind, which means history exists. If it's really important, we'll go back in history and grab it. But in a lot of cases, an ignored test, unless there's a clear follow-on item, like I've seen people go, hey, this test is broken, we need this other bit of infrastructure stood up before we can reasonably do X, Y, and Z, right? There's a comment, there's a link to some work item about what we're going to do in the future. Fine, right? That's That's one situation. Just flipping the switch to say, ignore the test with no indication of follow-up is often no different than deleting the test, except for it mildly slows down your test run.
Yeah, some larger factors this come into effect as well, where you're just, hey, I know this is broken. I'm going to say that that's an edge case, and I need to, just commit my work essentially, and then I'll fix that edge case. Like that's just part of the dev loop, and so it's not really, maybe that one isn't really ignored so much as postponed. The work of that is postponed, and you still want it to be there because that's a legitimate requirement that it's capturing, and you don't want that to go away. And so I don't know how you ignore tests. I guess I've never really ignored them, other than just looking at
good.
them
I won't teach you where the
saying
switch
like
is.
that's red, I'm ignoring this. That's my level of ignoring, and that's the one I like not.
Yeah, Mike Kern also comments that there's been studies that shown that typically velocity improves over time when you're actually adding in tests. And to some degree, this is completely anecdotal, can't back it up in any way. I think some of that velocity increase is due to developer happiness. Can't back that up at all, but I get happier and therefore I go quicker. So completely anecdotal, doesn't line up.
There is less burnout with tests. That's if you want to go towards the happiness, and the plight of all developers is burnout, and tests push that off.
Yeah.
Maybe not carrot, but they help a lot. So this is one of the things, and it wasn't one of the talks here, but I've had this conversation where people see tests as a cost and as a cost only. Like as a developer, like, hey, now every time I make a change, I have to go fix a bunch of tests, and that's like it's seen as a drag, and I think that comes from like most of that comes from just poorly written tests, which go back to again tests are written after are more fragile and therefore more likely to break, and so it's a feedback loop that if you can get on the test first, everything kind of starts. It's a positive feedback loop rather than a negative one, and you're inverting the spiral there. If you want to go to that other part, so for the rest that are not just terribly written tests and shouldn't do one is, I think the rest are actually a big benefit, because seeing a test that fails but isn't something that, oh hey, I just need to fix my code and make this test pass, like that's one change. But other times it's like, wait, why is this failing? Oh, I didn't consider the implication of this change having an effect here, and so needing to change that test forces you to reconsider what your system wants. What do you want your system to do in that scenario or in that part of the code, given this new piece of work or fix or something that you're working on right now? And so like having to change tests just makes me, okay, this is my thing I'm working on. Okay, this next test failing. Yes, I need to fix this. No, I need to rethink about this implication. You just go test by test until you get to where they all pass, essentially. That's either by fixing the underlying code or changing the test because the requirement has changed.
Yeah, and again, it goes back to that idea of the tests ideally should be tied back to requirements, not to implementations, right? And that's, like Artem was saying, that's the telltale sign of, was the test written early or late in the process? Not saying Artem's test detection is perfect, but that's oftentimes when you see a test that's really tied to that implementation and not to a requirement, it becomes a little more obvious. Okay, the only way you wrote this test is you knew what the implementation was. It's really hard to write a test that's tied to the implementation if the test came first. Right? Those things tend to follow one after the other. But being able to know that the cost of one of your changes is going to break a requirement implies that you have tests that cover requirements. Right? Even if that's not all of them, right? Sometimes we write tests that may not be directly tied to a business requirement, right? Maybe I want to write a test that asserts that, if I pass a null into this method, it throws an argument null exception. Great. Is that tied to a business requirement? No. May I want to test that? Sure, right? Like that is, to some degree, potentially helpful, right? Or in my case, with the library going against the web API, we wrote tests that say, you know what, when I make this call, darn it, I don't expect a null back in the following fields, right? I expect like a created date. Darn it, you can't give me an item that wasn't created. That doesn't make any sense. I expect those types of things coming through. Was there a business requirement that said we had to have it? No. There was a sanity requirement that said we had to have it.
One like example of this, I guess maybe not quite exactly what you're saying, but is like adding a parameter to a function. So like that's a you have to, and you have a bunch of tests that cover it, and you have to change them all, and or like it's changing, adding a parameter to an interface that you're using, so all the dependencies, and sometimes that's like, okay, now it makes me think about all the places that this parameter should be used and what it should think, but sometimes it makes me say, you know what, those are too many changes, I should reconsider my design. And that's like the seeing it at some point that's too many things. I don't want to touch that. That shouldn't be changed. I need to reconsider not just the implementation but the actual design of what my interfaces are.
Yeah, and that is very worthwhile doing. There's a very bad individual who may have written a DI container to do IL weaving to avoid those problems. Don't do that. That's bad. Don't let him near your code. Okay.
So this is the whole like you have to build this skill. Like it's a skill, and like I've one that I've pushed myself towards, and every time it gets easier and easier and easier. Do I still, as a big proponent of TDD, do I still practice test after or no tests at all development? Yes, I do. I'll admit that. Like that's reality. Like it's a mental effort to do this. Ask me a year ago how easy it was then, it'd be much harder than it is like now. And so you kind of have to build that muscle of being a better developer essentially by doing this.
Yeah, and again, I used the example earlier of this is like seeing somebody's vacation pictures that can only give you an idea of what it's like. It's not the same as actually working in it. There is a difference of people who have worked in repos and teams that do this, that they attack problems a little bit differently, and it is awesome to be in that situation. So think of this as us showing you a little picture of this wonderful vacation and telling everyone it would be great if you went and checked it out as well. Sorry, I keep clicking and then losing focus.
So this is for the brownfield, and this is going back to that same point of you have to do chunk by chunk. You have to let it infect, let it snowball into, hey, now this part's tested, now this part, and like pushing the boundaries of what you can codify into a test is kind of the important thing. Like, hey, there was this thing where like we used Kafka, and part of it was I had to have a server running, and it was really bad, and I didn't test it. Eventually, like, hey, maybe if I write this interface, if I refactor this, and like, yeah, that part is now testable. And it's like you build up tools. Part of it is like this tool set, unit tests, integration. All these are a tool set to allow you to capture design requirements ahead of time, and you slowly build that out for just you in general as in your head, but also for your projects and its dependencies of like, hey, if you use application insights, I have this library that essentially captures everything into a list, and I don't have to talk to real application insights because I can't mock it. Like stuff like that. Like you start building up, and it becomes easier and easier to work on the next thing, and it snowballs.
Yeah, I would also say too that your repo quality of your code is going to tend towards the quality of your tests, right? So if your tests are the Wild West, the code in your repo is going to tend towards the Wild West. If your tests are a nice pristine area where you invest a lot of time in refactoring, your code is going to start tending towards that direction. And most of the time people go, well, we don't want to make too big of changes that has too big of implications. That's not true if you actually have tests covering things. You know what all the implications are. You can see them, right? And more importantly, refactoring a test project, people tend to get, at least mentally, they get less twitchy, right? We usually aren't shipping our test projects anywhere. We can do big refactors to make our test code better, right? If it's like, well, shoot, this is a really painful setup. Okay, let's refactor, right? We can make factory methods. We can make our code in our test project cleaner. It's usually, people would consider it less impactful because it's not something that's shipped, but it's the foundation under which the thing that is shipped is being built on. So investing the time in actually doing it will make a big difference.
Yeah, because every time you take a bigger chunk because you feel more comfortable. Like, and this is a big, like, doing refactors without tests, and to some degree without a compiler. Sometimes, as I said, it's a test. It's like the amount that I feel comfortable with without just that fear of I'm breaking everything behind the scenes that I'm able to do. It just grows and grows and grows to where, like, I just some places I can just change half the stuff and, like, you know what, I'm good to ship it, like, because I can't test everything manually, but I'm sure it's covered in these areas because I'm confident of the coverage here.
So, kind of just in wrapping up, like Artem said, this is not something that will be easy or necessarily come naturally. Like anything else worth doing, it's going to take work, but the work is definitely worth it all the way through. So, questions, feedback? Don't everybody jump at once. Perko is throwing things at my computer, which is exciting. People online can't see, but we have multiple screens set up and everything, and she's trying to knock over my tower of dominoes that I've built. Just going through and doing this, we tried to go through and keep this at a little bit more of a high level as far as the philosophy, because getting people to make that mental jump is harder. Again, if people are struggling to practically write tests or figure out how to refactor those, talk to me, talk to Artem. Like, from a technical standpoint, that's the easy half of the problem. Right? Technical problems are easy. Getting people to make that mental jump is hard.
But the technical problems do sometimes create a roadblock to changing that mental thing. And so, like,
They poison the idea.
Yeah.
Yeah. I'll brag on one of our colleagues, Grant, pinged me the other day with a problem that he was working on. I rolled up to his desk to look at it, and he opened with, okay, so I wrote a test describing what I want to happen, and my heart leaped with joy. It was wonderful. I was excited. I was like, thank you, thank you, thank you. You can skip our talk. But that's what we ended up going with. Online, Corey, this presentation is getting me amped to go write some tests. Please do. Absolutely. Again, getting yourself into the state where you are comfortable making changes and being able to say, if the tests pass, we know we're fine. Like, that is an awesome state to get into. I know not all of the projects I work on are in that happy state, right? I always try to measure, what is my confidence interval? If my test suite passes, how confident am I that I'm not shipping something wrong? And some of those, it's like, about 60%. Yeah, it's not great. So, well, perfect. Thank you, everyone, for coming online. Thank you, everyone, for being here. Again, if people have follow-up questions and stuff, Artem, me, if you need our information, intelitech.com. All of the slides, I should probably have gone back. If you need to track us down, I don't know. There's probably a faster way to do this, but I don't know how to do it. Where's the one with the? There, ha! If you need to find us, information for those people online. If you want to try to get in contact with us, we're always happy to help go through and improve it. And thank you, Mike, for being in the chat. For those people online, Mike Kern is tester extraordinaire, no matter what he tells you. So, perfect. Thank you very much.